This is our sixth example of a proof using angles to prove lines parallel. And really the reason I call these an angle proof example is because most of what you're doing has to do with angles, and then your last step shows how to prove the lines parallel. In this case, this is a really interesting one, and it's one that also has quite a bit to do with quadrilaterals, but we don't really use any quadrilateral theorems to prove it. As far as I know, there's only one really good way to go about this proof. Not like some of the others that we've done where there's 3 or 4 or 5 different methods you could take. This one there pretty well is one method. And that is to use the information that you know about quadrilaterals. When I speak with my students about this one, we talk and we say, well, what do you know about angle A being congruent to B and C congruent to D? And essentially all they can tell me is, well, that means their measures are the same. Well, that doesn't help us a lot. So then we look at the picture and I say, what do you know about the picture? And there's only one thing we know about the picture. And that is that the angles in a quadrilateral add up to 360. And that's going to be what we use to do this proof. Because we want to show AB parallel to CD. So to do that, using what we've been given in this picture, the only real way to do that is to show that A and D are supplementary. Or B and C are supplementary. So the way we go about it is by putting our given statement in. That's our given. And then we are going to do, because we're going to use the measure of angle, we're going to use that polygon angle sum theorem. Let's just go ahead and claim that these angles are also equal measure, which is what our definition of congruent angles are. And that's just by definition of congruent angles. Now we use the polygon angle sum theorem, which says measure of angle BA plus measure of angle B plus measure of angle C plus measure of angle D equals 360. And that's just the polygon angle sum theorem. Hopefully you've learned this and you are able to calculate the sum of the angles in any polygon. And now, so essentially what we've done is taking a look at the given, wrote down everything we know about it, taking a look at the picture, wrote down everything we know about it. So really our only option at this point is to put those together. And so what we do is we do a substitution. And I want to show things about A and D, so I'm going to get rid of the B by a substitution. And then I'm going to get rid of the C by a substitution. So that was really nice, because now we only have A's and D's. So if I can prove that these two angles add up to 180, then I'm done. Well, I do that by doing some simplifying. Which we're going to call substitution. So I simplify things together. We call it substitution because we're essentially substituting in 2 measure of angle A for measure of angle A plus measure of angle A. That's what the substitution is. Then I notice that was really nice because I can divide out a 2, which gives me measure of angle A plus measure of angle D equals 180, which was good. And that's just division property of equality. And then that's good because that tells me angle A and angle D are supplementary. And that's just by the definition of supplementary angles. And that allows us then at the end to make our claim that we wanted to make, which is AB is parallel to CD. And we know that because of the converse of the same side interior angle theorem. That's how we know that those two lines are parallel, because we showed that this angle is supplementary to this angle, and those are same side interior or consecutive interior, whatever you call them. And then that shows us that the two lines are parallel.